So basically, neighbors algorithm is a classification algorithm and uses the conditional probability. Probability of A given B is equal to probability of A intersection B divided by probability of B, or probability of B given A has occurred is probability of A intersection B divided by probability of A. X will be your independent variables, Y is your dependent variables. Probability of X given Y or probability of evidence given outcome is known from the training data set. Probability of outcome given X evidence is what we need to predict in the algorithm. The naive Bayes algorithm for classification is the simplistic form is first we look at the simplistic form. Probability of Y given X. This is what we need to predict. We will predict it using this formula. Probability of X given Y multiplied by probability of Y divided by probability of X divided by probability of X. The naive Bayes algorithm for classification in machine learning is probability of Y given X is equal to probability of X given Y into probability of Y divided by probability of X. This if you have one independent variable. Naive Bayes algorithm for multiple independent variables. Generally, we have multiple, right? We have multiple independent variables. Is this. Probability of Y is equal to K. Probability of Y is equal to K given X1, X2, X3 till Xn. Probability of Y is equal to K. K means the classes. K means the classes in the dependent variable. The probability of Y is equal to 0 or 1 given X1, X2, X3 till Xn independent variables is equal to probability of X1 given Y is equal to K into probability of X2 given Y is equal to K into probability of X3 given Y is equal to K till into probability of Xn given Y is equal to K into probability of Y is equal to K is equal to K, probability of Y is equal to K divided by probability of X1 into probability of X2 into probability of X3 into probability of Xn. So this is the formula we need to use when you are looking at multiple independent variables. Multiple independent variables is there. We have to look at it like this. Here, P represents probability, and probability lies between 0 and 1. K is the number of classes in the dependent variable. A is the number of classes in dependent variable. X1, X2, X3, X4 till Xn, we call them as independent variables. We'll call them as independent variables. So simplistically saying, if you want to simplify this formula, the above complicated formula which is given, you can simply say it as the probability of outcome given evidence is equal to probability of likelihood of evidence, probability of likelihood of evidence. That means this whole calculation which you are seeing here, till here, we call it as probability of likelihood of evidence into prior probability, prior probability. Prior probability means probability of y is equal to k, divided by probability of evidence, divided by probability of evidence. The same. So this whole part which we see here, we call this as probability of likelihood of evidence multiplied by prior probability. Prior probability is probability of y is equal to k divided by probability of evidence. Probability of evidence is multiplication of probabilities of all the independent variables. Okay, so all of you got this? I know this sounds a little bit complicated, but once you do a small calculation, you will understand how it is done. Pardon? So this is a simplistic form. Posterior probability, likelihood, class prior probability, predicted prior probability. So this is the formula it uses to calculate various probabilities in the data. So I have sent you the calculation sheet. Got the sheet, all of you? So all of you can see the font size. It's okay. What is the dependent variable here? Stolen. The dependent variable okay, is stolen. Dependent variable is stolen. Independent variables, color, type, origin is your independent variables. So when you have the data like this, first step is you have to create cross tabulations. Step 1 is create cross tabulations of independent variables and dependent variables. You have to create cross tabulations of independent variable and dependent variable. Okay. Now, yes, no. What is yes, no? Stolen, right? Yes, no. This is the dependent variable, what we call as stolen. Stolen is our dependent variable. What is our independent variable? First independent variable is color. We have two types of colors, red and yellow. So we have two types of colors, red and yellow. This is your color. How many red cars are stolen? 1, 2, 3. 3 red cars are stolen. How many red cars are not stolen? 1, 2. 2 red cars are not stolen. How many yellow cars are stolen? 1, 2. How many yellow cars are not stolen? 1, 2, 3. Right? So total number of observations we have is 10. Got it? Cross tabulation with the first dependent variable. Similarly, we also need to calculate, we need to create a table like this for type. Type is sports and SUV. Type is sports and SUV. So how many sports are stolen? 1, 2, 3. 3 sports are stolen. 4, huh? 4 sports are stolen. How many sports are not stolen? 1, 2. How many SUVs are stolen? Yes, yes, yes. 1 and 3. Whatever is left out. Similarly, origin. In origin, we have domestic and imported. So how many domestic are stolen? 1, 2, 2 are stolen. How many domestic not stolen? 1, 2, 3. How many imported are stolen? 3 and 2. Now we need to calculate the probability of predicted, we are trying to calculate for the predicted. If the color is red, if the color is red, if the type is SUV, and if the origin is domestic, what is the probability of its stolen? You have to find out this probability. What is the probability of it being stolen? What is the probability of the Ferrari being stolen if its color is red, if its type is SUV, if its origin is domestic? You have to calculate the probability. Predicted probability if the color is red, type is SUV, origin is domestic. Okay. Now, what actually we are calculating is the probability of the vehicle stolen given X1, X2, X3. So let us say this is X1, this is X2 and X3, right? Probability of stolen given X1, X2, X3. X1 is, or you want me to specify if color, or let us say red. This is SUV. This is domestic. Okay, this is the probability we need to calculate, right? So what is the formula? Formula is probability of red given yes, probability of red given yes multiplied by probability of domestic given yes multiplied by probability of SUV given yes, right? Similarly, we also have to calculate probability of no given each of these variables. That also has to be calculated, right? Whichever has the highest probability, that will be the stolen stage. So first, let us calculate the probability of yes given these various arguments. Now, first, what we have to calculate? Probability of what is the first component? Red given yes. Probability of red given yes. What is the probability here? 3, right? Oh, we have to give the row totals also, forgot. Because row total is important, right? Without row total, you can't calculate, right? Is equal to this plus this. Drag it down, center it, Control C. So these are the row totals which you need to have for calculating the various probabilities. Let me just move the formulas to the side. Okay. Probability of red given yes is 3 divided by 5. Red and S is 3 divided by 5. What is the probability? 0.6. Probability of domestic given yes. What is the probability? Is equal to this divided by 5. 0.4. Probability of SUV given yes is equal to 1 divided by 4. Got it? Then probability of likelihood of evidence. Probability of likelihood of evidence is the probability of likelihood of evidence is equal to 0.6 into 0.4 into and 11. 0.06. Likelihood of evidence, right, on the top. See. See, what is probability of likelihood evidence? Probability of x1 given y is equal to k. Here we are calculating probability of x1 given yes. Probability of color given yes. Probability of red given yes. Probability of domestic given yes. Probability of type origin given yes. All these things is nothing but probability of likelihood of evidence, which is multiplication, right? We are multiplying all these aspects, right? That is what we are doing. Probability of likelihood evidence is the multiplication of all the three probabilities. Then we will calculate prior probability. Prior probability, which is nothing but probability of yes. Probability of yes. What is the probability of yes? Is equal to how many S's are there? 1, 2, 3, 4, 5. Total observations is 10, right? 5 divided by 10, 0.5. There are 5 S's. So how we got it is yes is 5 and no is equal to 5. And what is total? Total is equal to 10. 5 by 10 is 0.5. Prior probability of yes. Then what we have to multiply? We have to multiply probability of yes. What you call, you have to multiply these two. Probability of likelihood of evidence multiplied by prior probability. Multiplied by prior probability is equal to 0.06 into n13, 0.03. Got it? Now we have to calculate the other side of the equation, which is probability of no given red SUV and domestic probability of red and no, probability of domestic and no, and probability of SUV and no. So probability of red given no Okay, all of you completed the S calculation. Once you're done, please confirm. You want me to put the values here? This is 3 by 5. Why this thing is 3rd May? Why this is a 3rd May? This thing is date. This is 3 divided by 5. This is 2 divided by 5. This is 1 divided by 4. This is multiplication of all three. Got it, all of you? You can calculate for no also. Is equal to 2 divided by 5 is equal to 3 divided by 5 is equal to 3 divided by 4. Multiplication of all these three. Five divided by 10 is your prior probability is equal to 0.8 into 21, 0.09. The denominator is common for both the equations. So we don't need to calculate it. Denominator is common, right? So we can simply go with numerator importance. Whichever is having the highest numerator, that will be our, because the denominator is common in both the equations, which is probability of x1 into probability of x2, denominator is same. So which is highest probability? 0.09. So probability of no given x and probability of yes given x. We have calculated. This is this. This is this. So what is the predicted probability for this one? No, because 0.09 is greater than 0.0. So the predicted probability, if the vehicle is SUV, red color and domestic, is no. The probability of the car being stolen, if it is red color, if it is SUV, and if it is domestic origin, is no. Because the probability of no is greater than probability of x. No given x is given given x is greater than probability of s given x is high. So this is how the probabilities will be calculated by the algorithm in the backend. Exactly same process. Done, all of you? Done, all of you are done? So this is how the neighbors will calculate the probabilities for prediction in the backend, both in R, Python, any other software. We'll go to the second problem. Here we dealt with binary. In the second problem, we will go with multinomial, more than 2. More than 2. So shall I move to the second problem? Yeah. So the second problem is this, which you can see here. In the same sheet, I have given you the second problem also. Here, the dependent variable is what? Type of the fruit. The dependent variable is type of fruit, is the dependent variable. Independent variables are long, sweet, and yellow. Long, sweet, and yellow are the independent variables. Now, we want to find out what is the predicted probability if the fruit is long, sweet, and yellow is banana. What is the predicted probability of the fruit being banana if it is long, sweet, and yellow? What is the probability of the fruit being banana if the fruit is long, sweet, and yellow? That is the question. Predicted probability of the fruit being banana, right? So let us calculate probability of y is equal to banana. Y is equal to banana. So how will you calculate probability of y is equal to banana? How many total bananas are there? How many total bananas are there? Look at the total column. 500 divided by how many fruits are there total? Grand total 1000. Similarly, probability of y is equal to orange. How many oranges are there? 300 divided by total number of fruits is 1000. Probability of y is the fruit being other than orange and banana, it is 200 by 1000. Cumulative probability is equal to 1. Cumulative probability is equal to 1. Now, what we are trying to find is probability of probability of banana. Sorry, we'll say one. Probability of x1 is equal to long. What is the probability of variable 1 is equal to long? How many longs are there total? No, longs. 500 is equal to 500 by 1000. Probability of x2 is equal to sweet. How many sweets are there? 650. 650 divided by 1000. Probability of x3 is equal to yellow. How many yellows are there? 800 divided by 1000. Okay. Now, probability of x1 is equal to long given it is banana. Given it is banana. So what is the probability? Long and banana. So how many longs are there? 400. What are the total of longs? 500. Right? Sorry, what is the total of bananas? 500. So 400 divided by 500. Right? So long is 400. Total bananas is 500. 400 by 500. Probability of x1 is equal to sweet given it is banana. How many sweets are there? 350. Total number of bananas is 500. So is equal to 350 divided by 500. 0.7. Sorry, this is x2. Probability of x3 is equal to yellow given it is banana. So how many yellows are there? 450. How many bananas are there? 500. So we got 0.9. So what is the probability of likelihood of evidence? Likelihood of evidence is a multiplication of all these three, right? You will take the multiplication of all three as your probability of likelihood of evidence, which is equal to 0.8 into 0.7 into 0.9. 0.504 is your probability of probability of likelihood of evidence. Now we have to find out what is the probability of banana given it is long, sweet and yellow. Probability of banana given it is sweet, long and yellow. So what is the likelihood of evidence? Likelihood of evidence is this. What is the prior probability? Prior probability is this, right? So, sorry. Likelihood of evidence is 0.504 multiplied by prior probability is 0.5. The probability is 0.252. Actually, we don't need this because this is the denominator, right? This is the denominator at the for all the three. Now we have to find out the other parts, right? What is the other part? Probability of orange being long, sweet, and banana. We also have to find out, right? Then only we can answer with whichever is the highest predicted probability, we can answer that questions. So now we have to find out probability of x1 is equal to long given it is orange. Probability of x1 is equal to long given it's orange is equal to how many longs are there in orange? 0. 0 divided by how many oranges are there? 300. Now this is very important. When your probability is 0, there is something called Laplace correction. Laplace correction should be implemented. Laplace correction is to be implemented when probability is 0. So what Laplace says is impute 0 with a smaller value closer to 0. It is closer to 0. That is what Laplace says. Now we got 0. So I will make it as 0.05. This is Laplace correction since probability is equal to 0. I made it manually 0.05. 0.05. Otherwise, the whole calculation will become 0, right? When you multiply anything with 0. So you have to implement Laplace correction in naive Bayes. This is one of the common interview questions. What is Laplace correction in naive Bayes? It is, if the probability is 0, we have to impute it with some value closer to 0, as minimum as possible. As minimum as possible. This is 0.05. Now, probability of x2 is equal to sweet given orange. Given orange. So sweet and orange, how many are there? 150 by 500 is equal to 150 by 300. Sorry. Probability of x3 is equal to yellow given orange. What is it? Is equal to yellow and orange is 300 by 300. So the probability of likelihood of evidence is equal to 0.05 multiplied by 0.5 multiplied by 1. You got 0.025. Right? So as of now, if the fruit is long, yellow and sweet, it should be banana, because the probability of banana is higher. Similarly, let us calculate the last one also. For the probability of x1 is equal to long given other. What is the probability of long given other? Long is 100 by 200. 100 by 200. Probability of x2 is equal to sweet given other is equal to how much? 150 by 200. Probability of x3 is equal to yellow given other is 50 by 200. So probability of likelihood of evidence. Oh, sorry. Actually, we didn't calculate the other one here. We have to calculate this also, right? Let me just move them down. Control X. So probability of orange given long sweet is equal to 0.025 into a probability of orange, which is 0.075. Probability of likelihood evidence is 0.5 into 0.75 into 0.25. Probability of other given it is long, sweet and yellow is equal to this into probability of y is equal to other, 0.187. So what is the final rule? The rule is, if the fruit is long, sweet and yellow, prediction is banana, since the probability is highest for banana. Got it? So this is how we calculate. This is how the algorithm also calculates. You can calculate the things.